Hello everyone, welcome to Basics e-learning. In this video, I am going to discuss problems on discrete time signals. All these questions are from previous semester papers. So this video explains you step-by-step procedure on how to sketch any given signal using basic operations. The first problem I am going to discuss here in this video is a discrete time signal x of n is shown here. Sketch and label each of the following signals. So they have asked you to draw x of n minus 2, x of 2n and x of minus n. First study what is the signal that they have given. Here is the x of n signal. It's a discrete time signal. So that's why the notation is n instead of t. So at n you have different instants of n and you have different amplitudes of x of n marked here. So x of n is now is with an amplitude of 0 at 0 and with amplitude of 1 at 1, 2 at 2, 3 at 3 and 4 at n is equal to 4. So your x of n signal is extended from here 1 to 4, or you can say if you consider this 0 also, then it will be 0 to 4, or otherwise if your amplitude you are considering here from, so 0, 1, 2, 3, 4, where my 0 is here. So elsewhere you have your amplitudes are zeros, right? So now the first signal they have asked here is x of n minus 2. Your signal n is extended from, n has the range here, x of n has the range from 0 to 4. So if they are asking for n minus 2, then if you're asked for n minus 2 means what? Again, this minus 2 you add it to the range, right? So if you bring that to the other side, you will get everywhere plus 2, right? So that is, you will get, right, 0 plus 2, 2, n 4 plus 2. So that is 6, right? So your signal has to extend from 2 to 6. Now x of n minus 2 will have the amplitudes from n is equal to 2 to 6, right? So at whatever the amplitude of your x of n at n is equal to 0, now will go to n is equal to 2. That is, simply move the signal towards your right side by 2 units. That is, this 0 will fall on 2, 1 will fall on 3, 2 will fall on 4, 3 will fall on 5, 4 will fall on 6, right? So this 0, 1, 2, 3, 4 amplitudes are at n is equal to 0, 1, 2, 3, 4 respectively for x of n. Whereas coming to x of n minus 2, these amplitudes will be at n is equal to 2, 3, 4, 5, 6. As I said, n has the range from 2 to 6. So at 2 you have an amplitude of 0, at 3 you will have an amplitude of 1, at 4 you have an amplitude of 2, 5 at amplitude is 3, at n is equal to 6 you have an amplitude of 4. So this is how we can draw x of n minus 2. Coming to the second signal, x of 2n. Again, we have to find out the range here for n. The given range of the signal x of n is, if you are drawing 0 to 4, then for 2n, then just take this 2 to the other side. As you are multiplying 2 by n by 2 here, you just divide the range by 2 such that you will get the range for new signal. So 0 by 2 is 0, 2, 4 by 2 is 2. So our new signal range is from 0 to 2. Now, which two signals you have to draw? Right? So at n is equal to 0, n is equal to 1 and n is equal to 2. Right? The signal is starts from 1 and 2. Now at n is equal to 2, what is the amplitude here? 2. So simply you leave one signal and mark the other signal. Leave one signal, mark the other signal. As you're drawing for x of 2n, if you're keeping n is equal to 1 means what? X of 2 you will get. So x of 2, what is the amplitude? 2, that you mark. N is equal to 2 means x of 2 into 2, x of 4. What is the amplitude here? 4. So at x of 2n, at n is equal to 2, you will get the amplitude of 4. So these two are only the instants that we are getting for x of 2n. Coming to the third signal they have asked is x of minus n. So this is simply the symmetry of your y-axis. Along the y-axis you can draw the symmetry, as n has the range from 0 to 4 for x of n. Then for x of minus n, n range will be just multiply with minus on both the sides of your limits. So this will be minus 0 to minus 4. That means your x of minus n will have the range from 0 to minus 4. Right? So just take the mirror image along your y-axis. So at x of n, you have n is equal to 0 means you have an amplitude of 0, 1 means 1, 2 means 2, 3 means 3, 4 means 4. Now you take it reverse. X of minus n will have an amplitude of 0 at n is equal to 0, 1 at n is equal to minus 1, 2 at n is equal to minus 2, 3 at n is equal to minus 3, and 4 at n is equal to minus 4. Right? So this is how we can draw x of minus n for the given signal x of n. The second signal I am going to explain here is the discrete time signals x of n and y of n are shown. Sketch z of n is equal to x of 2n multiplied by y of n minus 4. So this is the signal x of n they have given, and this is for y of n. So you can write x of n here, that is extended from minus 3 to 3. N is equal to minus 3 to 3 with amplitudes. At n is equal to minus 3 you have 2. At n is equal to minus 2, 2. Minus 1 you have 1. Then 0, 1, 2, 3. So this is your x of n signal. So this is your 0 point. Similarly, I am writing for y of n also. Amplitudes are minus 1, minus 1, minus 1, minus 1. 0, again 1, 1, 1, 1. So this is also 0. This is n is equal to minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4. Right? Now, first you have to draw x of 2n. Then you have to draw x of y of n minus 4. Multiply the two signals. I'll explain now how to draw your x of 2n. X of n has the range. X of n has the range now minus 3 to 3, isn't it? This is minus 3 and this is plus 3. Now, we have to find out the range to draw x of 2n. So, for 2n, you take this 2 to the other side, just divide it with 2. Then you will get minus 3 by 2 to 3 by 2. So, minus 1.5 to 1.5. So, don't consider 0.5 and all. So, you take it from minus 1 to 1. The range for x of 2n, the new range is minus 1 to 1. Now, what are the amplitudes at n is equal to minus 1 and at n is equal to 1 for x of 2n, right? So, you just substitute n is equal to minus 1, you will get x of minus 2. So, what is the amplitude of x of minus 2 from x of n? 2. So, you mark it as 2. Similarly, you put n is equal to 1 here, you will get x of 2. What is the amplitude here at x of 2? Amplitude is 2. So, mark again. So, this is how we can draw x of 2n from x of n. So, this is simple. Next is y of n minus 4. So, n minus 4 means what? N has the range here from minus 4 to plus 4, right? N has the range from minus 4 to plus 4. Then n minus 4 means what? Take this 4 to the other side, add it. Minus 4 plus 4 to 4 plus 4 means 0 to 8. The signal has the range is from 0 to 8. Means the signal has to start at 8 and end at, start at 0 and end at 8. That means just move the signal 4 units towards your right side. So if you move at n is equal to minus 4, I have an amplitude of minus 1, that will fall at n is equal to 0 for my new signal, that is y of n minus 4. Similarly, at n is equal to minus 3, minus 2, minus 1, I have an amplitude of minus 1 that goes here at n is equal to 0 to 3. Then at n is equal to 0, I have 0. That comes to 0 plus 4, 4. Right? So at n is equal to 4, I have an amplitude of 0. Then at n is equal to 1, 2, 3, 4, I have amplitude of 1 consistently here at y is equal to y of n. So at y of n minus 4 means what? 1 plus 4, 5, 2 plus 4, 6, 7, 8. Consistently, I have an amplitude of 1 here, right? So, this is how we can draw y of n minus 4. What is the question they have asked? To draw z of n. That means you have to multiply. So, multiplication is simply multiplying the amplitudes at each and every instant, right? So, I don't have signal here at minus 4, minus 3, minus 2. Right? I have the signal only at minus 1. At n is equal to minus 1, x of 2n has an amplitude of 2. Whereas for y of n minus 4, amplitude is 0. So 2 multiplied by 0 is 0 at n is equal to minus 1. Next, at n is equal to 0, you have 0 multiplied by here amplitude is minus 1. So again 0. Then here at n is equal to 1, x of 2n has an amplitude of 2 and y of n minus 4 has an amplitude of minus 1. So 2 into minus 1, I'll have minus 2 amplitude at n is equal to 1. Then the rest here from 2 to 8, the further signal is 0 only for x of 2n. So whatever it may be the amplitude of y of n here, you will get only 0, right? So 0 multiplied by any amplitude of y of n minus 4, you leave with 0. So my z of n signal is a single impulse at n is equal to 1 with an amplitude of minus 2 is the resultant signal after multiplying x of 2n and y of n minus 4. The last problem in discrete time signals in this video is x of n is equal to 2 power n into u of n plus 1 minus u of n minus 4. Then sketch the following signals, that is x of n minus 3 and x of minus n plus 4. So first we have to draw x of n. So unlike previous problems, they have not given x of n signal, but they have defined 2 power n into u of n plus 1 minus u of n minus 4. So first we have to evaluate what is this u of n plus 1 minus u of n minus 4. This is very common question in board papers. So here u of n plus 1. So what is u of n? U of n is equal to 1 for n greater than or equal to 0. Means the signal is like this 1, right? So till infinity it is amplitude of 1 only, starting from n is equal to 0, 1, 2, 3, right? So this is your u of n. Then what is u of n plus 1? Again, u of n plus 1 is also equal to 1 when n plus 1 is greater than or equal to 0. Means n is greater than or equal to minus 1. So the signal here starts from n is equal to minus 1, right? So 0, 1, 2, 3, 4, everywhere you have an amplitude of 1 here, isn't it? So till infinity. Then u of n minus 4 again is equal to 1 when n minus 4 is greater than or equal to 0. Means what? N is greater than or equal to 4. That is the signal starts from 4. Right? Till that point of time you will have only zeros. So at 4, 5, 6, 7 till infinity you have an amplitude of 1. Right? So this is u of n plus 1 now, and this is u of n minus 4. What they are asking? U of n plus 1 minus u of n minus 4. So simply subtract the amplitudes of these two signals at each and every instant of time n. Right. So at n is equal to minus 1, I have here what? Minus 1, right? So, sorry, at n is equal to minus 1, we have an amplitude of 1 and here this is 0. So, 1 minus 0 is 1, right? So, you will get at u of n plus 1 minus u of n minus 4 I am drawing. So, at n is equal to minus 1, I will have an amplitude of 1. Then, here 1 minus 0, again 1. At n is equal to 1 also, 2 also, 3 also, I'll get amplitude of 1, right? So 0, 1, minus 1, 0, 1, 2, till 3 I'll get an amplitude of 1 here. At 4, 1 minus 1, 0. At 5, 1 minus 1, 0. Everywhere it is till 1 only, till infinity, right? So 1 minus 1 you will get 0. So the signal is extended only from minus 1 to 3, right? Here, I'll explain you one tip here. See here. N plus 1 to n minus 3 means the signal will extend from minus 1 to 3. Right? So, because at 4 you will be getting that 0 only. Right? 4 minus 4 you will be getting at n is equal to 4 you have an amplitude of 1, and again at n is equal to 4 you will have amplitude of 1. Right? So, how to get these limits? The upper and lower limits. So, you take it n plus 1, that lower limit you take it as to the other side minus 1. For upper limit you take n minus 4 is equal to 0 means n is equal to 4, right? That you subtract it from the lower limit minus 1, that you will get 3, right? So minus 1 to 3, your signal is extended from minus 1 to 3. After seeing the signal itself you can guess what is the range of your signal, right? So this is your u of n plus 1 minus u of n minus 4. But they are asking you to multiply this, we call it as amplitude scaling, right? 2 power n, that is at x of 0. The signal is extended from minus 1 to 3, no? Means x of minus 1 will take, right? So x of minus 1 means what? 2 power minus 1 multiplied by, at x of minus 1, what is the amplitude? 1. So 2 power minus 1 multiplied by 1 means 1 by 2. See here. At n is equal to minus 1, I have given an amplitude of half. Then at x of 0 means 2 power 0 multiplied by an amplitude of 1. 2 power 0 means 1. See here I am marked. Then at n is equal to 1, 2 power 1, 2 multiplied by 1. So that is 2. At n is equal to 2, 2 power 2, 2 square multiplied by this signal value is 1. So 4 multiplied by 1, 4. At n is equal to 3, 2 cube multiplied by 1. So that is 8. See, this is how we can draw x of n. Now we'll see how to draw x of n minus 3. Now x of n has the range from minus 1 to 3. Now x of n minus 3 will have the range, just take this minus 3 to the other side, minus 1 plus 3 to 3 plus 3. That is 2 to 6. Signal has to start from 2 to 6. N is equal to 2 to 6. Then what about the amplitudes? Just shift the signal towards your right side by how many units? 3 units. Then just this at n is equal to minus 1, I have an amplitude of half, that will come here to 2. 0 will fall at 3. 1 at fall at 4. 2 will fall at 5. At n is equal to 3, I have an amplitude of 8, that will come to 6 here. So this is x of n minus 3. Right. Then x of minus n plus 4. Right. So x of minus n plus 4, first you have to shift and then inverse. That is, you have to shift the signal first by 4 units. First we will see x of n plus 4. Means n has the range from minus 1 to 3. N plus 4 means take it to the other side. So n plus 4 will have the range of n minus 1 minus 4 to 3 minus 4. That is minus 5 to minus 1. Right? So first you have to take the signal range n as minus 5 to minus 1. As they are asking for minus n, then what happens? N has the range from minus 5 to minus 1. Then minus 1 will have the range from 5 to 1, or else you can take it 1 to 5. Right? So the signal has from 1 to 5. But in the reverse order, as they are taking minus, that is the inverse version of the signal you have to take. So draw it in the reverse way. So half amplitudes, all the amplitudes whatever we have, half, 1, 2, 4, 8. Then those signals you take it from n is equal to 5 to 1. That is, here you have half, 1, 2, 4 and 8. So this is x of minus n plus 4. For more videos, please do like, share, subscribe to our channel. Let us know your suggestions and queries in the comment box. Thank you.